Hi everyone. Hi everyone. So my name is Christopher Adigun. I'm a cloud native telco architect. So in this video, we'll be going through one of my blog posts and see how we can do the demo via this video. So I released this blog post about 6 months ago, but then I just want to do this video so as to kind of like explain some other things that some people might be curious about. So this is about using LoxiLB as an SCTP load balancer in front of the AMF. And LoxiLB is one of the cloud native projects that can be used for as several kinds of load balancer. And one being the SCTP load balancer, and it's also based on eBPF, which makes it a bit fun, right? So and then the 5G core will be Open 5GS, and everything we'll be doing will be via the kind Kubernetes cluster. And the reason for the kind is I chose kind is just to make it concise so that we don't make it too much complicated, like using several virtual machines. But this can give you an idea of how, even if you want to replicate this on separate VMs in your Kubernetes cluster. So a quick run through of what we'll be using. So I've said we'll be using LoxiLB, and we will be making use of Multus also. Multus will create an additional interface in the two AMFs and also in the UE simulator, which will be my 5G RAN sim tester, and then also in the UPF. And also the same Multus will also create some other interfaces in the LoxiLB stateful set. Then for the Multus, I've decided to peg this to a particular release based on, I just picked the version 3. So I think that should be okay for most of the Kubernetes cluster that you currently have. So take note, if you want to use a different Multus version, maybe version 4.0, you should be careful of the manifest file that you'll be using. So because if you just pick the default manifest file, you might run into some issues because the manifest files are not tagged based on the image versions. So that's just one thing to take note. Then we'll be using, I have 3M charts, right? One for the LoxiLB, one for the UE Genobi simulator, and then one for the Open 5GS. So we'll just run through the creation. For instance, we have, let's create the kind cluster. So, oh, sorry, we need to move into the repo. So if you have not, just clone the repo and you have all the files, and then you can start. So for now, currently we are picking the latest stable release for kind, which will install a 1.27.1 Kubernetes cluster. So to make this demo a bit fast, I've already created this kind cluster so that I can pull the images that it will be needed. You can also do that irrespective of kind, right? You can pull the Docker images down so that it will be a bit faster. So now you see it's bringing up the cluster. Once the cluster is up, then we'll proceed with the remaining steps. So while that is going on, let's see the other aspect that we need to look at. So to simulate the multiple interfaces in the Docker container, I'll be using Koko. So Koko creates additional interfaces in what do you call it, in Docker container. So this will help us to create the additional interfaces we need for Multus. Ideally, you will create additional network interfaces based on the hypervisor you are using, but I think Koko has made it it has made it much easier for us to do this. So you can see the link is there also, and I really appreciate the effort that was given into this. It makes it easier to use a Kubernetes cluster like kind. So let's see. Okay, so our cluster is up. So let's do a normal kubectl node. Okay, so we have two worker nodes and the control plane. So the next step we need to do is to do the Multus installation. So the Multus installation is I'm going to check from the chip system namespace. So we see that it's in the init state. So let's do a watch and see just to see when it's to come up. So let's see other points that we can also look at. So I'm creating the namespace before we start, but it doesn't really matter. You could add this creation of the namespace in your Elm install command also. You can do that. It's a matter of choice, right? So you could add the flag that is a M flag to add to the to your M install command to instead of creating the namespaces beforehand. So I've already downloaded Koko, so we can. Okay, so we see the Multus is up. So let's check if we have Koko installed. Yeah, we have Koko installed. So let's create the namespaces. Yeah, let's confirm that we have the namespaces up. So that's up also. So the next step is to create the virtual interfaces. So we are injecting ETH1 into the two worker nodes. So if you can check Koko out yourself. So since I already have Koko installed, it's already in my executable, so I don't need to do this. I'll just add the koko command, and then so I need to add a sudo. All right. So now we have the ETH1 injected into the worker node. This step is very important. Without that, then your Multus will not work. So these I've already done this also. So you need the SCTP module to be installed on your virtual machine. So then, because kind does not come with the CNI plugins, and when I mean by the CNI plugins, what I mean is like the IP VLAN, the MAC VLAN binaries. So that's why we need to do this. So in some Kubernetes distro, you don't need to do this. Some comes by default. Some you have to create it just the way I'm doing it. So you need to check out as it relates to you. So let's see. Okay. Let's see if the install CNI. Okay, so yeah, so the install CNI daemon set is also up. So the only thing it does is to create the IP. In this instance, we are using MAC VLAN. So now that's done. And one of the reasons why I'm breaking this down in terms of the manifest, you could also add this manifest into the Helm chart, okay? But then to make it a bit easier for those who may not be too familiar with Kubernetes or Multus, you could read these YAML files easily, and it will give you a bit of what is going on. So we'll create the Multus interfaces. So this, to go through Multus in this video, it will take a separate video. So if you are not familiar with Multus or Multus in Kubernetes, you can check out I have a course also on Udemy that tries to do, that creates, that can help you out. So now we are installing the Open5GS, and then we are installing it in the Open5GS namespace. So if we check that namespace out and then do a get pods. So we see also that, so let's do a what? Now we have some conditional statements. For instance, we need MongoDB needs to be up before other CNF that require it. What are the CNF that require MongoDB? You have the PCF. The PCF requires MongoDB. The UDR also requires MongoDB. So you see that's why these are like is still in init, because they are waiting for the MongoDB pod to come up. So once the MongoDB pod is up, then every other then you have the sequential initialization of the remaining pods. So we wait a bit. So I'll come back a bit once the pods are up. Yeah, so the pods are up and running. So what I actually left out is actually the NRF2 needs to be up before every other, of course. To not that this is so super important in Open5GS, because it has like it keeps trying even if the NRF is not, but for you to minimize the number of restarts. So that's why we have to put the init container to wait on the NRF and then the MongoDB to be up for some of those CNFs. So this import, what this import is doing here, it's essentially to create the subscribers. So instead of having to go all the way into the web UI, you could actually use a Kubernetes job to do the initial creation. So if you check the let's check the logs for that pod. So you'll see that it's actually it's creating two sets of subscribers. So you see these the IMSIs, right, and the remaining parameters. So yeah, it's picking up the Open5GS has a utility, a bash script that you can use to import. That you can use to create or manage subscribers directly inside the MongoDB database. So since our pods are up, our Open5GS pods are up, the next step we need to do is to do the LoxiLB chart. So this is also in a separate namespace, which we call the LoadBalancer namespace. So if we go into that namespace also, we do get pods. So we ordinarily we should only see just one pod there. So the content, it's also in container creating, and we can let it once it's running, then we'll come back here. So maybe let's just go through some of the LoxiLB chart. So you see, you only have the stateful sets, right? And then once the LoxiLB starts, once it starts, what we are just doing is we are actually injecting the command that will be used to configure the two AMFs as the backend. So this, if you check in the values.yaml file in the LoxiLB chart, you actually see the command we are using. This is the command we're actually using to create the load balancer entry for the to sit in front of the two AMFs. So you see, this is the VIP that we are using, and then by the time this same VIP will be referenced in the my 5G run test, right? So you see here, so in my 5G run tested M chart, so we see that we have this AMF VIP instead of the individual AMF, and also we have to make use of the LoxiLB as our gateway, which is mandatory because we are using the one arm architecture. So let's see if so the container is still in container creating. So let's I'll come back. Okay, yeah. So it's even up. So we can proceed. Let's move on to the next step. So the next step will be to actually create the UE simulator and the GNOB simulator. So of course you could make use of UE ransom if you want. There is no real particular reason to choose my 5G RAN tester. So also this goes into a different namespace. So the namespace is RAN simulator. So if we do the get pod, yeah, so it will take a while also for this to come up. So if we do a watch also, let's see if it comes up shortly. So like once it's up, then what we do is we can exec into the simulator, and then we can now try to see if we can connect using the VIP. So, but before then, just to confirm that we have an interface injected into the AMF port. So if we exec into one of the the AMF port, then we do an IP address. So here you actually see that you have the Kubernetes primary interface, and then you have the Multus interface. So this is 3.3. All right. So that's just to confirm to you that we indeed have a Multus interface. So let's check the simulator pods again. Yeah, so the simulator pod is running. Let me bring that up. So since it's running, the next step is let's exec into the RAN simulator itself, and then do so. But before then, let's go into the LoxiLB pod also and see that we the current state before we proceed. So the command to test that is the LoxiLB get city. So yeah, you see that we don't have any current context or sessions running. So inside the my 5G RAN sim, we can do this to initiate just one UE session. So we see here that now it's saying once you see UE is ready for using data plane, then it means the attached sessions and everything was successful. So you can see here that the GNOB, the AMF IP we are using is 2020.1, which is the VIP IP of the LoxiLB. And if we come back to this and then run this again, then we'll see actually that this has been, and then if you see it's using 3.3, which is one of the AMF interfaces. So you see 2020.1 is the source IP, which is from my 5G RAN sim, and then it's showing you how it's doing the destination NAT, and this also shows you how the traffic will probably go back to the source. So let's see, this is 2020.1, then this is the source IP, which is my 5G RAN sim, then the port, and then it's NATing it to its own to the LoxiLB IP, and then it goes out to the AMF pod IP. So like I said, so this once the AMF will respond back to the 3.1, and then since this will be the source address, so you see it as the source here. And then take note that the destination port here matches the source port here, which is from my 5G RAN sim. And then it will now do a source route back to show that the traffic is coming from the VIP, then back to my 5G RAN sim here, which is 3.2, which shows the 3.2 here. So that's basically the run through of how this this goes through. And also, if you just want to check the if you want to to look at the data interface, right? So you can also the data plane for the my 5G ransom. So like I said, if you see this, you see that you have the UE plane, the UE tunnel setup, but then this by default is always down. So like I said in this post, you can just you can just bring it up. And then once you bring it up, then you can initialize your ping via the UE 21, then you could ping the UPF, or you could also ping the internet. So this is just to test the end-to-end connectivity. So I hope this video was useful to you. Kindly share with with others you think this might be useful with, and we'll see you in the next video.